Good afternoon, everyone. We're thrilled to welcome you here today for our Modern Machine Shop panel discussion on the benefits of CNC retrofitting, as well as some compelling case studies. My name is Ryan Adamovic, and I'm delighted to be here today on behalf of Fagor Automation, a leading provider of CNC control systems and high-accuracy encoders. We work very closely with both OEMs, integrators, and high-level end users to ensure top-notch performance and precision in various manufacturing environments. Before we begin, I have a quick housekeeping item. We are just 45 days away from IMTS 2024. We invite you to join us at the East Building, booth 134140, where you can experience the latest and greatest from Fagor Automation. Additionally, we'll be hosting daily seminars on various topics from right within our booth during the show. It's a fantastic opportunity to learn from the best and stay ahead of the curve in the world of CNC and encoder technology. Now, back to the topic at hand. There's no denying that investing in a fresh new machine from an OEM can be a game changer for any business. The latest models come with cutting-edge technology, advanced features, and enhanced capabilities that promise to boost productivity and precision. New machines can streamline processes, reduce downtime, and deliver superior performance, making them an attractive option for companies looking to stay ahead of the competition. However, it's important to consider the strategic advantages of retrofitting existing machines. Retrofitting offers a cost-effective alternative that allows businesses to leverage their current assets while reaping the benefits of the latest features and functionalities from modern technology. By upgrading control systems and components, retrofitting can significantly enhance the speed, accuracy, and reliability of older machines. This approach not only reduces the financial burden associated with purchasing new equipment, but minimizes production disruptions during the transition period. Fagor Automation relies on our network of factory-authorized integrators, FAIs, when it comes to breathing new life into existing equipment. Today, we have an FAI expert that's not only worked on a large variety of machines, but has exclusively offered Fagor controls since the inception of his business. Local to the Chicagoland area, making this panel discussion possible, we have Farzad Ahmadpour, President and founder of FAMA Technology. He will be sharing his insights and real-world case studies that highlight the transformative power of CNC retrofitting. Lastly, at the end of the discussion, we will have a live Q&A session where you can submit your questions to both FAMA and Fagor Automation. To submit your question, simply type it into the chat and it will be answered at the end of the discussion. Thank you for joining us today. Without further ado, let's get started with our panel discussion on the remarkable benefits of CNC retrofitting. I'll be handing it over to our CNC sales manager, Arthur Gogolski.
Thank you, Ryan. We are here today with Farzad Ahmadpour, President of FAMA Technology. Welcome.
Thank you for inviting me.
Thank you for your time. We appreciate your stopping by and giving us the opportunity to discuss retrofits.
I appreciate it.
Can you tell us a little bit about FAMA Technology?
Right. FAMA Technology started at 2012. And Fagor has been our main activity, as far as installations, services, and everything since we opened up. We have had so many retrofit projects across the country, from west to east, from north to south, everywhere, and different factories, small and big. We have had different type of machines that we worked on during many years, lathe, mill, grinding machines, honing machines, like even we had folding machines that we worked on, and retrofitted the whole machine. So we used Fagor in any type of machines that you could imagine, pretty much.
So FAMA is an exclusive Fagor factory authorized integrator for a very long time.
Right, for a long time.
Yes, our topic today is retrofit. So what does it make sense to consider retrofit Or when does it make sense to buy a new machine? Why is it the option for retrofitting still people should consider?
I think the most important part of retrofit is you are actually trying to make the machine to work to your benefit, to solve your specific problems. Those problems could be like the machine breaks down so much, or it is obsolete, or you cannot find parts, or you really like your machine and the structure of the machine, but the controller or the electronics are not capable or modern enough for what you exactly want to do. You like the accuracy of the machine, but the machine doesn't, for example, operate a good CAD/CAM software, or it's not very easy to use. You cannot find people that actually know how to program those machines. Basically, to solve specific problems, you're supposed to, I guess, use the best out of your existing machines. I would say the cost is the major component of this. So if you want to buy a new machine, you have to spend a lot of money, and you have to wait for a long time sometimes to get a machine. And when you get a machine, it has its own problems always. You know, it's not like magic. It's it's built the same technology on some other places, and then you have to wait for that factory to build a machine for you, and then you have to install it, and then during the installation you find problems and everything. But if you have a machine installed in your facility for a long time, and you are very familiar with everything on that machine, the machine mechanically is safe and sound, there is no major wear and tear, or so you don't have a major deformation on the structure of the machine, then you can easily just update the electronics.
Yes. Okay, so just to summarize, I think from the business point of view, when is the best moment to consider retrofit? When the machine is very large, big and heavy, sound has to be like mechanically working.
Or a unique machine.
Or unique machine. And I think
you
also,
find in the market.
I notice sometimes the machine is still running, but the operator who runs the machine for, let's say, 30 years retired, the company hires a new machine operator, and they are not capable to run the old machine the way they ran in the past. So even if the machine is still operational, you still want to update the electronics.
Exactly. For example, we had projects that the machine is fully functional, but the way that they had to program, or they have to program still, for the different machines. So we upgraded one machine, and they had several more machines. That the programming technique is so obsolete and very cumbersome, but the new controller is some tapping on the screens, yes, and entering some little information, you have all the programs ready for you.
Yeah, and also I think from the business point of view, when you compare a purchase of the new equipment, which comes with the new system, you have to install it, you have to have a foundation, many times you have to get a new tooling, compared to the existing machine on the floor. If the price of the retrofit project is half the price of the new machine,
right,
you may just consider to move on with the retrofit.
So I can give you an example that they had a very large machine that I retrofitted, our company retrofitted, and the machine was built a long time ago and transported to the facility, and they put a lot of machines and the building around that machine, so it was pretty much enclosed. So it was not even practical for them to move the machine out of the facility. Yep. The machine was functioning.
So to move it to make room for the new one.
Exactly.
Yeah, okay.
So it wasn't even practical to take the machine out of the building. They had to tear down the building to be able to do that.
Yes.
So examples like this, a machine that is functional or mechanically usable, you just change the electronics, and then you could have something like a brand new machine which operates the same as if you would buy a brand new machine.
That's right.
It would be the same exact thing.
Yeah, that's a good perspective. So you had a long, extensive background working with Fagor system. So when did this started to have a first retrofit project? When was that?
So yeah, that was back in 1999, and they bought a machine, a used machine, an NC machine. the machine was mechanically pretty accurate, and it was a very large machine, actually 10-meter travel on the X gantry machine. It was a milling machine with tool changer and with hydrostatic, so it could lift, move a very heavy load, and 50 kilowatt spindle on a milling machine. That's huge. But the electronic was outdated, completely outdated. They were thinking only make the machine run for us, so just make it work. And when I got involved, I'm like, that would be too much of work, because now you have to understand everything. The machine was like in pieces, and the electronic was very, very old. So I suggested, let's retrofit this machine. Let's actually put a new electronic on it. So back then, for me, it was like a major decision, because you had to do major, change the motors, change the drives, put a new scale, put the new controller, write the PLC from scratch and everything else. And we had, after that, we had an extensive research. Like, we want to retrofit the machine. Which controller? So we had plenty of options, obviously. And so my criteria was find something that is easy and powerful, obviously. It has to do the job, has to be able to do the job. And as easy as possible that you can learn it and not invest so much time and energy to actually get the software, get everything that actually you can work with the controller. So I did a lot of research and I found Fagor. And I'm glad that I could find Fagor. It was pretty, it worked for me, worked very well for us, everybody. So that's the story. We actually try to find a controller that is as efficient as possible as far as the cost, performance, features, and user friendliness. And our customer, they loved it too.
Yeah, that's a good story. Mm-hmm. So what cornerstone of your services, of your business, help to excel in the retrofit?
I think our only criteria is how to solve problems. So I think we really listen. We listen to people, to customers and their actual needs. We're not trying to make artificial problems. The existing problems, that's what we're attacking to solve. And I think that resonates with people. People actually like, a service person or a company that actually really understands their problem and try to solve those problems. This way, and obviously you have to be as creative as possible, as open as possible, because not every problem is the same, and not every customer is having the same, demand, or sometimes operations are different. Sometimes you have very, very knowledgeable people, sometimes not so much, and they want just the work to be done, and it's a production machine, and they don't want to invest so much time on using programming the controller, or that's. But some other companies, they have all the sophisticated tools and knowledge and everything that actually can operate the machine. So you have to listen, and you have to deal with the process. You have to actually. The other thing is we try to be as open as possible and involve the customer in the process, actually, in a way that they feel like they own the process.
That's right.
Their technology, their knowledge.
This is their machine still.
Exactly.
So I like when you say the problem solver is number one technique or cornerstone of your business to help retrofit customers. And I think open means, like our logo, open to your word. We are trying to help the customer offer the full solution, full package. But initially, we only have to address a problem, or that problem, whatever is the reason they call you. And I think maybe you have some comments about it, but we can offer solution which is required at this moment. Let's say change the control system, but keep the spindle and other motors still on the machine. Sometimes I like to call it a progressive retrofit. Progressive meaning you start with the number one problem the customer call you about, but you continue and give the customer a possibility for the next budget, for the next year, to offer a full package solution.
Exactly. So the thing is, you have to start from a problem-solving position that the customer know. So the problem that the customer know that they have. Sometimes the customer, they have problems that they really don't know.
They don't know yet. Yeah. Okay. Yeah.
And this is where you have to actually try to educate your customer. Try to see if what you're trying to offer has any value to the customer. The customer knows that the value that you're offering is on the table, and it is his choice now, or her choice. So, basically, this is another thing that we always do. We try to start, and then I have many examples like that. Like, for example, there was a very large G&L machine, and the first thing that we did, we only upgraded the controller.
Yes.
The drives were analog. The machine worked, and everything was okay, but it wasn't as accurate or as responsive or as like perfect that they would like that machine to be. It was a very large machine. So then the next phase, we said, we can solve all of these problems by adding, let's say, motors and Fagor motors and Fagor drives and and the scales.
And the scale, linear feedback, high precision.
Linear feedback, exactly. And we only use the absolute, and then the machine, performs like much better and more efficient. So they really liked everything about that machine, and then they got a project that had about 2 micron accuracy for such a large machine. They didn't care about the time of the machining, but they cared very much about the accuracy. It was some military thing. So then we offered volumetric compensation. And volumetric compensation is like the machine has some inaccuracy because of the geometry of the motion, but the Fagor 8065 controller that we used had the ability to do the volumetric compensation. And then we actually collected the points and compensated the machine. Very tedious process and everything, but the machine had that ability. So the old controller, you could not even imagine to ask these kind of questions or solve these kind of problems.
Yes, so this is a similar example to dual feedback. The volumetric compensation lets you bring the mechanically dated machine to the highest level of getting yourself a new machine.
Right.
And again, you don't have to move it, it's already in place, you have the same tooling. So yeah, those are the savings for our customers,
Exactly.
For many machine owners.
I think
machine tool owners.
When you retrofit a machine, you're going to see things that you would feel like this machine is not a magic. It's just everything is getting, broken down to pieces that you understand every piece. And then because you have this knowledge, then you know what to expect or how to improve or what can you do with your machine. I guess this is the most important part of this process of retrofitting. The magic becomes something understandable.
So what were the other tools and skills you used, in your retrofit project history to gain those projects, to get those acceptance?
I would say, again, because customers are different and the demands are different, we have to understand what exactly is the customer that is asking, and then try to actually accomplish that task. If it is accuracy, then obviously you have to always go back and try to be as honest as possible that if you want, because accuracy is expensive, always is. You have to go back and try to explain the whole situation. And then, so if you explain the details and educate your customer, then the customer is going to basically have a very clear mind and can choose very wisely.
Yes.
If it is worth it to do that or not. So it won't be a black box for them. I guess our key success point is we are not making anything black box. We are trying to we are ready to explain every single detail that the customer would like to know. And that, we prefer the customer to maintain the retrofit after we've done the retrofit, but it's not like if people want black box turnkey package, we deliver a turnkey package and we maintain it, but our preference is to educate.
What are the cases you would like to share with us of your successful retrofit machine tools, or sometimes I know you mentioned routers or stone cutting machines.
Right.
Whatever is big, it's worth to retrofit.
It's more impressive, I think. The bigger.
No, but also from the business point of view, it makes more sense to fix the big equipment because of the new machines, prices.
I am specifically proud of two projects that we have done. One was a very large VTL machine with 3 spindles and 3 channels and 11 axes, and a rotary table that could precisely stop, because it was a tandem C-axis, the rotary table, and it could unclamp the C-axis and the spindle would kick in and it would be like a VTL. And it had a side milling, and the whole table could come out like Y-axis and in. So basically you could do off-center.
So it's also not only multi-channel, but dual-purpose machine. This has a milling and turning heads.
Exactly. So this is like, and it had a tool changer, actually 2 tool changers. So this is like the most complex thing that you could imagine on a machine, because multi-channel, large machine, tandem axis, multiple, many axes, 11 axes that machine had. We put scales on all the axes. Actually, it was a major retrofit. We actually rebuilt the machine too, like scraping all the beds, changing all the ball screws, everything. So it was a major retrofit and rebuild. And the machine was a Titan machine made in Romania, I believe.
Yeah, Eastern European, yes.
Eastern European, one of a kind. They made only one machine and that's all. They didn't make any machine like that. So if you want to buy a machine like that, you had to find somebody who actually understands the whole process and then make the machine for you if they ever would. So they bought the machine. The machine had a Siemens controller, and but outdated. And we actually replaced the whole electronics, drives, motors, scales, everything, PLC.
So this would be in my progressive retrofit kind of story. This will be the full package. This is your end goal when everything is brand new on the machine. Everything electronic.
Exactly. And the machine had to make 4 different parts as quick as possible, like very large valves, as quick as possible for, I guess, a Canadian government water project or something, as many as them as they wanted. And then it had to be, the machining process has to be cheap enough so they can actually, the customer would accept. So that means speed. You needed speed.
So I think the saving is also because being a multi-purpose, dual-purpose machine, you can hold the job on one setup.
Exactly.
And without moving the job,
mill from the top, mill from
finish
the side,
all the functions.
Turn again.
Yes.
Do every possible
live tool on the spindles.
Tooling, live tooling.
Rigid tapping.
Oh yeah, many rigid tapping. And precision, because it had the O-rings, because it is a valve, so you have to.
Actually, I've been helping you with this project.
Right.
I think one of the
Fagor helped me so much.
One of the key factor was having 11 axis multi-channel configuration. We created the M codes to switch in the fly. What are you doing now, Mr. Customer? Are you milling?
Milling?
We have an M code for mill.
Exactly.
Are you turning now as like a vertical lathe?
Exactly.
We activated the live spindle. We call only the axis you need on the screen, and you continue working on the same job using a different configuration. So our strength in this case was flexibility. We can offer on one CNC platform multiple setups.
And you had 2 different stations, actually 2 monitors, 2 keyboards, and controlling 3 machines in one place. One side of the machine you could change the tool, you could do a lot of manual operation, and the other side of the machine was actually running a program. And then the other side would wait for this side for another program in that channel to kick in, and then they simultaneously work. Actually, the programming wasn't easy for that particular valve or the valve sets that they were making, but after it was done, the machine was just producing without stop, no intervention, and then so you have a one setup, and then you finish the part, and you put the next one, and you put the next one. Otherwise, you had to move the part, and the errors that you may get and inconsistency that you may get from one part to the next part, all of that. So that was the only option. The retrofit was the only option on that, that case.
Or buy the new machine, but this kind of machine would be not only expensive, but very long delivery.
Exactly.
Up to probably 1 or 2 years.
Oh, probably not even possible. That machine is not... if you want to buy a machine like that, someone has to design the whole structure, and it probably will be like $10 million.
How about custom made?
It won't be cheap. It will be, that I can tell.
So what are the other cases of the strength of the package and your, very modest knowledge of tuning?
Sure, yeah.
Help you to get the goal?
One of the other projects that I'm really, I'm proud of is South Bend lathe, actually 2 of them, now 3, like a grinding on rubber. So they had to cure rubbers on a very large cylinders and grind it to a bulged shape, concaved or convex, and with pattern on it, and that was a production machine as well. So, and they wanted to program everything with just no programming knowledge. So we had to make the machine as flexible as possible, as accurate as possible, and as easy to use as possible. So
through the menu, so like a user cycle HMI.
Cycles, exactly. So we developed 5 user cycles for setup and for different operations. They had to do, like with a saw, they had to make patterns, and the pattern had to be like in a spiral pattern, and then it would go on the other way, and then you had to stop in the middle, and then, but then they would punch some numbers on some screens that we designed, and then voila, you have your part.
So no need for CAM software.
No need
At the end of the day, everything operator can, or the owner of the machine can hire the new operator, teach them how to run it, enter a couple parts.
In a couple of days. You could actually run that machine. And if you want to write a CAD/CAM program for any of those parts, it would be thousands of lines and a very sophisticated, like 3D modeling in a computer, and then posting, and then if something has to change, you have to go back, and then you have to change it, you have to post it again. But there, you just punch a number, change like the radius, or change the bulge, or change the whatever, and then start, and then it does it. So because, first of all, you can customize the screens, you can have customized screens, and the other side, you have powerful enough controller that can do all the macros and the sophisticated algorithms, with any formula that you would think of.
So just to clarify from our audience, our Fagor controls are capable to do G-codes and all the master CAM or CAM software post-processing, XYZ, generated programs. But in this case, it was a lathe which has a grinding heads, the saw, the belts. So in this case, it was quite sophisticated to understand the tooling and create the right macro and the interface to make it work. But actually, also it helped to sell new machines from Taiwan.
Exactly. So
and that machine has also turning cycles for cutting metal and capable of doing macro programming. Yes?
Right. So they had 2 machines. We retrofitted the first one, and then the next one to South Bend. And then they bought another machine from Taiwan. Summit Machine Tools. They bought another machine from Summit Machine Tools from Taiwan, same size, a little larger for the chuck, a larger chuck, like twice as bigger, so they could do bigger parts. And then we customized that controller too. The controller had all the conversational cycles and everything. They use it. Don't get me wrong. The embedded conversational cycles, they are great. I mean, lathe, I guess nobody can compete with Fagor as far as conversational and lathe. But apart from that, they added our screens from the other machines onto this machine, and then they had the same capability on those machines too. So bottom line, the cost of programming or on-site or at the machine programming is going to be substantially much lower, yeah.
Good, that's a good story.
So the other thing I would like to say is, as you definitely know, Fagor is a commonly used controller for router industry. And router, basically, like the 5-axis routers, large routers and everything. Routers are essentially like the cheaper side of the machine tools. Why? Because they use steel frames. They're big, but they're not.
Well, but they still, sometimes they cut expensive materials, advanced materials like composites.
But why they're able to do that, why they can actually attack those very accurate projects with a very inexpensive machine. How is it? Why? Because of the power of tuning and the power of geometry compensation that Fagor can offer. So basically the electronics actually can make a not very expensive machine to perform as a very expensive machine.
That's right. Yeah.
This is the beauty of the whole process. If you know how to basically do the fine-tuning, Fagor fine-tuning or your own expertise fine-tuning of the axes, to make them work simultaneously, multi-axis, let's say, 5-axis, head and everything. If you know how to do that, and then you incorporate the volumetric compensation or cross compensation and everything with laser, so you can actually make a machine like be as accurate and as agile as possible. And that's what makes Fagor very
ready for the challenge. Yes.
For the challenge, exactly.
Even for the cookie die machine for
Right.
Oreos. Yeah.
Yeah, so that was another project that I want to explain about. So there is a company that still would like us to do the rest of their machines. We just finished one. And that is like, so they make rollers for food industry.
For food industry, yes.
Those
Heavy parts. Yeah.
Very heavy parts, exactly. So they make millions of, let's say, chocolates, or so you have a little cavity, a little cavity, and the chocolate, for example, or the material is going to be flown onto that, and then it would roll, and it would be frozen to a very low temperature inside, so it would solidify really quick, and then it would turn, and there's a little nozzle that actually push out the cookie or anything, Oreo, for example, that particular.
So it's a mold for the food industry.
Right. But the challenge is two things. First of all, it has to be done very fast. So intricate design, and many of them.
Yes.
So you have like sometimes in those M&M, the little chocolate thing, like so that you have 1 million cavity in one roll.
Yeah.
And you have to make 1 million cavity in 1 week. So to be able to do that, you have to have multi-spindles, and you have to actually set the spindle to a certain distance, and then they have to work together. So that particular machine had 10 spindles, high-speed spindles, like 40,000 RPM spindles, and they had to work simultaneously with the roller turning and the XYZ moving at the same time, and it had to have enough accuracy and speed and everything, to be able to do the job properly. And we have done one, and hopefully we're going to get another 5 and then another 9.
Have you done any projects at the universities of schools?
Yes, we have actually done a project, an automation project with precision motion control to make parts for CERN. CERN is a laboratory, actually the largest laboratory for high energy physics in the border of France and Switzerland, and actually the largest particle accelerator. And we are making some mirrors with some reflective material that is 99.99995 reflection rate, and we're making 100,000 or 120,000 mirrors, precision mirrors, with a machine that we designed. Actually, they designed and we did the automation part of it. So to make those mirrors, to send it to CERN in Europe to actually capture dark matter.
But where's the machine? The machine is
in NIU,
oh, okay.
the Northern Illinois University, and the physics department and the engineering department are actually taking this project, and then they did the design. We had so many interaction with them, tried to help them to do the optimal design and everything. It's an automation with precision motion to just wrap those mirrors around some patches of little pieces of plastics. And it had to cut the foil, that 99.999%.
So those are actually
material.
like a production part. They have to produce a lot.
They have to produce really, really quickly and very, very precisely to basically wrap around. So there was a little electronic inside of that mirror that the whole giant array of mirrors supposed to reflect back to the little electronic sensor, like a CCD sensor, to collect the information after the particles are hitting each other to find out if dark matter exists or not.
So if somebody can see the machine, will be in DeKalb, Illinois.
Right, right.
So in conclusion, from all those applications we discussed, what is the lessons you can give to the prospective integrators who are probably watching this webinar today?
So I would say the most important thing is, if you have a problem, don't try to live with it. A problem has to be solved. And if you basically, if you want to solve your problem, you have to find the right people and the right technology to do that. The problem, the solution of the problem might not be reachable, but that doesn't mean that you have to really ignore it. You can probably always find a solution for any problem. So I guess basically is embracing the technology is always a solution. And not to be afraid of incorporating what is out there into your operation is going to have a lot of benefits. So I would say, if you feel like you have some problems that can be solved, please reach out. And that was my the whole life story, actually. Problem occurs.
That's right.
And you want to see what you can, what kind of accomplishment you can have to attack those problems. It's not about actually the problem; it's the learning process. It's a learning process.
Well, we have a good track. Examples of problem solutions we have accomplished, and working together with the right integrators, with the right hardware, software, we can fix those problems for you.
Yep.
And I think that's the key. That's the key.
And I believe we are in the right place. We feel certainly like that, like we are in the right place, a very good family of very, very knowledgeable people, and accessible products and completeness, the features, being on top of the problems. And we feel like we belong to a family here, at Fagor.
Thank you.
Thank you.
Thank you for that.
No problem. Thank you.
Thank you, gentlemen. Don't go anywhere because up next we have our live questions and answers. To ask a question, simply type it in the chat bar and one of our panelists will address it. Thank you.